Notice the difference between these three. Number 13, I simplified. I got all root 3s, so I could combine them. Number 14, there were some root 3s, some root 2s, just a 25. Nothing combined, so you just say done, or you just circle at this point. And then number 15, only those first two terms ended up as root 2s. So I combined these two, but you just leave that root 3 alone because it doesn't have any other root 3s that it can add or subtract with. All right, our last rule for square roots is that you can never, ever, ever leave a radical in the denominator. That means a square root or a cube root or a 11th root, but we're not going to deal with anything except for square roots. Next year you will. There's a few different things going on here, and so let's take a look at a couple of these and we can have some different approaches. Number 16, I can't leave a square root in the denominator, but don't forget that list from earlier. These are both perfect squares, and so you just evaluate each of your square roots and you are done, and you don't have to worry that there's a square root left in the denominator. For question number 17, shoot, there's a square root in the denominator, but we, at the very, very beginning, we didn't write it down as a rule, but the square root of x times y, in order to simplify, we broke that up into the square root of x times the square root of y. And I mentioned that it's true for multiplying or dividing. Well, here's where it's dividing. If I have the square root of x divided by y, that is the same as the square root of x and the square root of y. It's really important that they're both square roots, but other than that, you can use these rules forwards and backwards. We used them forwards to simplify our square roots. We used them backwards to do that second group of questions that was multiplying two together. And so here we're going to actually use our rule backwards and smush these together. 20 divided by 2 just gives me the square root of 10. I'm not done. I do need to make sure that when I branch, I don't have any pairs. Nope, just 2 and 5, and so we're done. All right, let's try that on number 18. Let's see if we can get that to work. Just ignore the 5 for now. It's really a 5 over 1. You can even split it if you want, and then I'll write the radical part as 18 over 8. Well, I can simplify this, because 2 goes into 18 9 times, and 2 goes into 8 4 times, but shoot, I can't simplify anymore. Well, notice again that your square roots are perfect squares. I'm going to now split it back up. I have 5 root 9. I have, 1 root 4. I know the square root of 9. I know the square root of 4. I get 15 over 2. So I am trying to avoid doing what we call rationalizing, that I'll show you in a minute, by trying to do other tricks first, because then often those are easier. Let's see what happens, though, for 19 and 20. Number 19, I don't have any fractions, so I guess all I have to do here is simplify. I'm going to go ahead and smush these two together. Root 3 times root 3 is root 3 times 3. And if you either think about 2 of a kind, I have 2 3s, or you think about the square root of 9, my answer here is 3. That is going to be true for any radical that you have. Now, 3 is nice because it's always prime, but I could also do something like root 9 times root 9. Yeah, sure, do each. That's 3 times 3. I get 9 as my final answer. Or you smush them together and you get root 81. Yep, square root of 81 is still 9. Or you smush them together and you go, oh, look, I have a pair of 9s. And still I get my answer of 9 for this problem. So question number 20 here is just saying whenever you have the square root and you have a number squared, like 3 times 3 or 9 times 9, those two things undo each other and you just get an x. Next year in Algebra 2, you're going to talk about actually you have an absolute value on there because there's stuff going on with positives and negatives, but we're saving that for next year. Don't worry about it this year. We are going to use the facts from 19 and 20 to help us make number 21 work. I smush them together. I get 3 over 5. Well, that didn't do me any good. It didn't help me at all. Instead, I have to do something else in order to get rid of the square root of 5 on the bottom. And that something else is very limited because this is an expression. This is not an equation. An equation, you're allowed to do anything you want as long as you do it to both sides. But an expression, we can either add 0 or we can multiply by 1. And so we are going to multiply by 1, and we're going to make 1 like what we want it to look like. We want to get rid of the square root of 5 on the bottom, and so we're going to multiply it by another square root of 5. But if I multiply the bottom by root 5, I have to multiply the top by root 5 to make sure that I'm not changing any values. The square root of 5 over the square root of 5 is just 1. All right, on the top, 3 and 5 are both prime, so I know that they're going to not have any pairs, and so I'm going to go ahead and just write root 15 on the top. On the bottom, root 5 times root 5 is 5 by design. You cannot simplify this any further. I know it's tempting because of the 15 and the 5, but this 15 is locked inside this square root symbol, and you can only simplify inside together and outside together. And since the 5 is outside, you can't touch those two things. For other questions, you can do this as well. So multiply top and bottom. The only problem on the bottom here is the 5. And so I'll multiply top and bottom by root 5. You're not done when you do this. You want to make sure you always are looking for more simplifying. So I'm going to have 3 root 6 times 5 over this 5, and then another 5 from the 2 radicals times. And then I've got to think about this square root and see, can I simplify this square root anymore? Well, 6 I'll break up into 2 and 3. So I have a 2, a 3, a 5. Nope, there's definitely going to be no pairs, which means my answer will be 3 root 30 over 25. There is one last thing I should check. I should check if I can simplify the outside numbers. Luckily here I cannot. 3 over 25 does not simplify, and so we are done. There is our simplified answer. One last one that I'll do, and then you can try the rest of these before we do one last thing. You can try these in different orders. If you want to multiply the top and bottom by root 12, you can. If you want to simplify the square roots first to make all the numbers smaller, you can. It doesn't really matter. So I think what I'll do here is I'll keep the 2 and the 3 on the outside. So I'll write those down. I think I'll go ahead and I'll simplify this 200. That's going to be 2 times 100, which is going to be 10 times 10, which is going to be 2 and 5, and 2 and 5. And I'm going to write all of those under my square root. So I have 2 times 2 times 2, and 5 and 5. I'm going to go ahead and simplify my 12 out. So I have 2 times 6. I have 2 times 3. I'm going to pull anything out that I can. So on the bottom, I have a pair of 2s that I'll pull out. Up on the top, I have a pair of 2s. I have a pair of 5s. I'll kind of do all my simplifying first. Let's see what we get. The 2 is still just out on top. The 3 is just still out on the bottom. I pull out that pair of 2s. I pull out that pair of 5s. I have a 2 left in my radical. I pull out the pair of 2s. I have a 3 left in my radical. I can simplify because there's a 2 and a 2 on the outside like that. And now I still have to rationalize. So now I multiply top and bottom by root 3. All right, let's see. That's going to give me on the top a 2, a 5, a root 6. On the bottom, that's going to give me 3 times 3. Again, I'm going to check, does anything simplify on the outside here? It does not. So finally, I've got my answer, 10 root 6 over 9. I don't tend to do this. I usually will just rationalize pretty early in the process because I find sometimes that I end up having to simplify again and again and again, and it's just easier sometimes just to rationalize right away. That whole process of doing the times root 3 over root 3 is called rationalizing. But you pick whatever order you like doing them in. I'm going to actually just post the answers with all of the rest of these done. So let's do out these last 2 problems before I turn this off for now. Let's remember multiplying. We've done a ton of this. So I multiply. You can do your FOIL acronym if you want. Don't love it because it's really just distributing. When I go ahead and multiply with all my branches, I get 2x times 2x. That gives me 4x squared. I get 2x times plus 5x. I get 2x times minus 5x. And then I get minus 25. When we have 2 conjugates, that's what these 2 are called, where they're exactly the same and one is plus and one is minus. These 2 terms in the middle will always cancel each other out, which means I get 4x squared minus 25 here. We're going to use that to our advantage on question number 27. You could try 27 beforehand if you wanted. If we multiply top and bottom by root 2, we could try, but we have to distribute. So on the top, I would get 3 root 2. On the bottom, I would get 4 root 2 plus 2 times 2. Great! I got rid of this one, but I made another one in here. So that doesn't help us at all. Instead, we have to multiply by the conjugate of the denominator. So I'm going to copy the 4. I'm going to copy the 2 root 2. Of course, anything I multiply the top by, I also have to multiply the bottom by. It's a plus on the original, so I'm going to multiply by a minus. We did all those factor cancel ones, and I told you parentheses are helpful, so I'm going to do that. I'm going to put all my parentheses in. On the top, I'm going to go ahead and distribute. On the top, I get 12. The 3 and this 2 are outside, so I get minus 6 root 2. And then on the bottom, I'm going to do my complete distributing all out. I get 4 times 4. That gives me 16. I get outside, inside, so minus 8 root 2 and plus 8 root 2 to cancel out. And then I get minus 2 root 2 times 2 root 2. Well, these 2 give me a 4. These 2 give me a root 4, which is just a 2. And so I get minus 8. I'm not done because we have to, of course, do our subtraction. I have 12 minus 6 root 2 over 8. It looks like we're done, but we have one last step because now this is a factor cancel. On the top, I'm going to factor out a GCF of 6. I'm left with 2 minus root 2. On the bottom, I have an 8. I can cancel. 2 goes into 6 3 times. 2 goes into 8 4 times. And I'm left with my final answer, which is this. All right, so try the rest on the sheet. I will post, along with these videos, all of the answers for the whole sheet. And good luck. Please make sure you mark off any, try them all, try the homework, and then we'll go over anything you'd like tomorrow. All right, thanks, everyone.